Welcome to the webinar on paths. This probably will be one of two webinars simply because I have quite a lot of material to cover and I don't want to rush it. So my name is Andy Emmerson. I'm a senior consultant with Lana, have been for 25 years, and this webinar is to talk about paths. After the webinar there will be a blog placed on our website which you can download with links into the models, so you can download the models and take a look at them. The form of the blog will be something as we can see in this Word document, which will explain in some detail the kind of materials I'm going to be talking about today. So you shouldn't need to take much in the way of notes, and anything that you do need, if you've forgotten anything, then if you get in touch with us afterwards, we will communicate information to you. I have a number of models I would like to show you over the course of today and the second webinar session, if we do one, which I think we will, on paths as well. This first one is one taken from the training course, and it uses two machines and it has two labour items and they are linked by paths. The path is a special element in witness that many people do not use, and that is of course one of the reasons why this webinar is going ahead. The path element should not be confused with the path display that you can put on buffers, conveyors, tracks and on power and free sections. So those are physical elements which can have a path display, whereas this is a path element. And the use of a path element is to introduce travel time into models where motion and time is important. So if I set my model running, and quite slowly, we can see that labour moves along a path to collect parts from a goods inwards buffer, takes a part to the machine, does some work on it, carries a part to the second machine, where he does some work and a supervisor also arrives to do some supervision, and at the end of the process labour and parts disappear along other paths. So I'm going to stop this and do a rewind and step forward so we can see what's going on. First thing that happens is a part arrives in the goods inward and the machine requires the part to be delivered to it. The labour sets off and walks along the path. You'll notice that the labour direction changes so that he's always moving facing forwards. Goes to collect the part, carries the part with him along the path to the machine. The machine then starts working. So all of that time the witness clock, the time clock, was moving. Without paths, of course, the part would appear instantaneously. So the labour attends the machine, and on completion of the cycle, labour then carries the part to the second machine, attends the machine, and the machine goes into state waiting labour because we require a supervisor who comes along a path, joins the operator, the machine works, and on completion all three go back to their home position. The labour has returned home because there's no other work to do. So I step on, and in the meantime a new part appears, so the operator gets to his home position and continues straight through to collect the part. This time we can see labour, a part is already available in the goods inwards, so on completion of the task the labour in this case will take the shortest route to get the part and to bring it into the machine. If we take a look at the rules on our machine M1, and I'm just going to double click on it with the left mouse button, then the pull rule, rather than being pulled from goods in, which is the name of the buffer, is pulled from goods in with operator using path. If I look at the labour rule on the machine, I say operator using path. So if an operator is not present at the machine, then they will come along the path. The hash or #1 indicates that I require one item of labour. I don't need to have that pounds or #1 there, but if I had a quantity greater than 1, then I would need to specify it. The output rule is pushed to machine M2 with operator using path. and we can see our operator duly goes to machine M2. The input rule for M2 is wait, because as we all know, we don't want to be pushing and pulling across the same boundary. One of those two machines needs to take control. The labour rule for machine 2 is it requires an operator using a path and a supervisor using a path, and that is why our machine M2 goes into state waiting labour until the supervisor arrives. At the end, we say push to ship using path, and the part will go to the ship, and the labour will return to its labour queue because we have enabled it to do so. And we do that through the model options paths dialog. Model options and paths. In here we set up the basics of our path network. We have enabled the paths to be bidirectional, which is why the operator can go in both directions along path W3. We have enabled labour to walk to idle, which is this list like queue here, this pathway, and we've also enabled labour to walk from idle to collect a part. If these were disabled, the labour would disappear from the machine on completion and return instantly to its rest or idle position, as we normally see with other models. We have enabled multiple path routing, so labour or parts can be moved from one location to another along a network of paths, providing that network has been set up. And in this case, the operator can go along path W1 to the machine and then along path W6 to goods in. So by using those two paths, they can collect a part, single path to machine M1, single path to machine M2, and on completion the operator can then, if required by the goods in, can then take path W3 and W6, or path W2, W1 and W6 if he so desires. Okay. If I double click on any one of these paths, let's go to W3. This is a detail form for the path, and it allows me to set up how the path is linked. In this case, I've enabled it to collect from machine M1, and its destination is machine M2. In Witness, we can have multiple destinations and sources, which is quite useful because then you can have a single path which goes from a group of machines or desks to another group of machines or desks, thereby meaning we don't need to create so many paths. We've also got the travel time set on here, and we can set this time either by hard coding in a time value or by storing it in a variable, which we've read from, say, Excel, or we can allow Witness to calculate it automatically using the walk time function. There are several functions in Witness which are linked with paths, and I've just extracted some of them from the quick reference guide which you get with Witness, and here we have them. Particularly the ones of interest: the path destination, return the name of the destination, the length of the path, the X dimension of the path, so going left to right across the screen, the Y length of the path going up and down, the source which matches the destination, the physical path length, and various other items in here which give us quite a lot of power. So those are all available in the quick reference booklet, and of course by going onto the online help. You'll also find some good information if I go to model options paths again. If I click on the help button here, there's some good dialogue here that explains what all those various settings mean. And one of the most interesting ones is this walk time function that we have enabled in Witness, which allows us to set the walk rate of parts if we wish it to be done automatically based upon the length of the path. At the moment, the walk time is in path W3 the default setting, and that default setting is based on the length of the path in pixels and the walk rate that we set in the model options dialog that I've just closed out of. I'll come back to that in just a moment. What I want to show you is if I take the path here, I click on it, you can see handles at either end of the path. I can select any of those, and by holding the control key down, my cursor changes from a 4-way arrow to a 2-way arrow, and I can move it around the screen. Similarly the other end. And I can select on the middle and I can break it and change my path. If I do that, of course my path gets longer. So previously I was recording the time that the operator joined and left the path, and it was 4 time units. If I now do it, you'll probably find that it's longer. And in fact you can see what has happened because we have fastest route optimization on. The operator now reckons that this is a shorter route to take than going along that path, so they take that shorter route. If I shorten my path down to try and encourage the operator back along path W3, then, and again you see I didn't need to restart witness to do that, these changes take effect immediately. The operator is now travelling along the path and the walk time is now 7 because the path is proportionately longer. Okay. We have in Witness the path editor, so as well as being able to create paths just by defining them from designer elements, dropping them on the screen and stretching them to size. I can also, if I wish to, open my path editor, which is on the separate toolbar, and on here I can populate my path. So for instance, I may wish to put a curve into my path, and there are a number of options I can have from drop down. So there is a pre-configured set of options which we can customize. In this case I'm going to stay with this one, which has given me an 8 pixel length turn of 90 degrees, and I can alter whether I'm turning clockwise or anti-clockwise, and I add that on to my path. And then I can say let me add a length onto it. So let's say 40 will do, and I can add a length of 40. Oops, I'm in the wrong place. I want to grow upwards. Then I want to change my direction of orientation and go along to the right, and add another straight into the right. Then I'll turn down again and add another straight. Then I'll turn back in the other direction and I'll add a final straight of 10. So I'm being able to put curves into my path now using the path editor toolbar. There is again good information on this in the online help, and I shan't spend too much longer because I guess you can find it fairly easily just by investigating the online help. The one thing I will show you on the toolbar, which I seem to have managed to close, there it is we have an information dialog, and these are the catalogue of various settings we can put in when we're configuring the drop-down contents of these two boxes. And we also have some information specific to our path, which tells us what we've added in here and allows us, if we're working in a 3D world, to change it so that at some stage here we actually have a height gain of 2 units, so we keep going up in the air along the top and then back down the other side by putting a -2 in. You won't see that until we build into 3D world, which I'm not going to do this time because I don't have the latest version of Witness 14 on my machine at the moment. Maybe next time I can show that if people are interested. So path editor toolbar, very useful indeed if you want to do more complex paths and choose not to do it by clicking and dragging. Okay, let me open another model and we'll talk a bit about the walk time function, which I've mentioned briefly. Oh, before I do that, let me just show you, if I right click on my path and go to update graphic, that on the path display here, as well as displaying how the path itself will appear on the screen in terms of its size, thickness, colours, etc. I can also choose how parts and labour relate to each other. So I can choose to have the part and the labour leading and following, or going side by side. If I have leading and following, I can choose to be one in front of the other, as we have now with -12. So if I just remind you what we're looking at the moment with our operator going along here. So at the moment the part is in front of the operator. If I were to change the path display, rotate it up and make that a +12 and update, when I move onward next time the part follows the operator. So I can change the orientation, the relationship of the part and the operator as I desire. Okay, second model I'm going to open up now is crane paths with walk time. So here's another quite simple little model. I'll just zoom a little bit, and if I step it going, we will see a part arriving at machine M1, and then the crane will come on completion of cycling, moves along to path. And you'll notice that while I'm doing this, the clock is advancing, the machine is finished working, it's in state blocked, it's waiting to export the part. The crane arrives, picks the part up, I timestamp it, it then moves along the path to machine M2 and deposits it in a buffer, and then either goes back to rest or to pick up the next part. And in fact another part is already waiting here, so it carries straight on, selects the part and goes on to machine M2. You'll notice that in the header band of Witness we have the pixel positions, the XY coordinates if you like. So 0, 0 is in the very top left hand of the screen, which my cursor is pointing at now. I go up to the top there, and then we increase in X going across the screen, and we increase in Y going down the screen. So if I position the cursor at the beginning of my path, I can see my coordinates around. My X coordinate is 200. If you can see in the layout window, after the 190%, the first figure, the X value is 200. If I position it at the right hand end, you can see the X value is now 620. That means my path length is 420 pixels. If I go into model options and to the coordinates page, I can see that I have a conversion factor that will convert my pixels to whatever units it is I wish to work in. This factor is currently 10. If I go to my paths phase, my walk rate is currently 1. So in my path itself, if I look at the walk time function, the walk time function calculates the time to travel as a path length, which is 420 divided by 10, 42 units, divided by the walk time, which is 1. So my time along the path should be 42 time units. If I start my model and take a look, in fact I set it running, we will see I'm timing it along here, and my transfer time will indeed be 42 time units. If I go back into model options and change my walk rate to 2, so I'm walking faster, double the speed, and I run my model again, we should this time see that our walk rate will be 21 time units. And if I change the length of my path, because this time is based on the travel time is based on the length of it, then I will find that my travel time along the path will vary in relationship to the path length. So if we have our paths laid out on a physical layout, on a CAD layout, and we change our paths around, we can see then what effect it has on the efficiency of our model because of the greater or lesser path time. Okay. If I go into Model and enter my user actions, you can see I've got some of the functions that do this calculation separately displayed. So when I press the user actions key, I'll print out these following messages. First of all, it'll use a function called path length to tell me how long the path is. Then it'll get me the mapping factor, which was 10. Then the mapping unit, if I want it, which could be meters or feet, whatever you like. And then finally, I can print out the path length divided by the mapping factor. So, if I press my execute user actions, you can see the information. I'll just drag this up a little bit. Displayed. So, my length of my path is 420. There's my factor. Those are my units. And that is my length time to travel along it. So these are some of the functions that, as well as being used by Witness in the modelling, also allows us to interact and manipulate our models and gives us a great deal of flexibility. Okay, time's running on now, so I'll go to one more model before I'll invite any questions to come up. And I'm going to open Crane Paths with Walk Time 2.mod. For short's sake, save any changes. If I go and check here my model options, conversion factor is 10 still, my units are meters, my path walk rate is 1, and we'll notice this time that path from M1 to M2 has been extended. And if I run my model now, the crane cuts apart and travels along this new pathway, and we can see our new travel time being rather than 42 time units as it was before, is now 52.95. If I look at model options for paths, we can see that we have the bidirectional paths option is set is on. We have multiple path routing set to off, and fastest route optimization set to on. If I were to enable multiple path routing, that does give me the crane the option of returning along more than one path. So if I were to run my model now, we can see that the crane decides that this is a shorter route to take, so it takes that route in preference. So it is important when we're building our models to be absolutely sure which of these options boxes to tick. Generally, you can do some trial and error and you will find what will work for you, but getting the right combination of these buttons pressed is quite important. Okay. I have been talking for around about 25 minutes now. I do have about 3 or 4 other models I'd like to go through, which I think we'll have to carry over till next time. But I would be interested to know if anybody has any questions, anything you'd like to go over on what I've talked about so far, and whether indeed you would like to come back to a further webinar in the future on which I cover things such as variable speeds along full paths and pseudo paths, having parts moving at different speeds depending on part type, and showing how we can link multiple pathworks together into a larger network. And seeing as I have got a few more minutes in that case, I will move on to the next model just to show briefly some of the things we can do. So I'm going to open up variable speeds along a path, and in this model I have 2 different part types travelling along the paths, and you can see they are at different speeds. If I look at my path, which is a walkway, rather than using the default function, which relates the length of the path in pixels to a defined walk rate, I have got a function of my own called calculate path speed, which is active. And if I look at that built-in function, that function checks this value, this attribute luggage label attached to my part, and if it looks at the part and identifies it as a full part, it travels at one speed. If it is an empty part, it travels at another speed. So simply by executing that function, every time a part joins a path, it will assign the correct travel time for the part, which means you can have multiple parts on the path and parts overtaking other parts. So that really is quite a useful piece of functionality that you can have. And it can do the same thing in pseudo paths. So here again I have two machines sending parts along a pathway to machine M3, and I'm using pseudo paths as before. If I go and take a look at my model options paths dialog, then on here, every time a part arrives on a pseudo path, it picks up the time as being this variable VR travel time. VR travel time is displayed on the screen here, and it's executed on actions on entry. So every time the part leaves machine M1, machine 1 or machine 2 to go along a pseudo path to machine 3, depending on the part type, the travel time will be set. It uses the walk time, which is the distance between the two machines. In this case I divide 1 by 2 and multiply 1 by 2 to get a noticeable difference in speed. The machine rule, again, pushing to machine 3 using path. Because there are no physical paths created, witness will attempt to send parts along a pseudo path. A pseudo path is an imaginary line drawn between elements along which parts will travel. Model options, paths. To make that to work, well, I could turn all of these off because I have no path elements in the model. All I have is pseudo paths. So as long as that is enabled, then my parts will travel along a pseudo path, and you can see that while a part is moving, the witness clock is advancing. If I were to make the mistake of having pseudo paths turned off, and witness is still trying to push along a path, then I will get an error message. It can't find a path and it stops. It's quite reasonable to do so, I think. Okay, so we've seen 2 or 3 models on simple parts of paths. There is more we can talk about, but given the time is now advancing and the session was due to end at around 4:30, I think this is the time when I shall stop speaking. The webinar will be available for download in not too long a time, and the models will be available for you to take a look at as well, as will the blog, which has a number of words wrapped around the models, which will hopefully help you find your way through. I want to thank you for your attention and your time, and I hope you've got a lot out of it, and have a good day.